And good afternoon. Today we are the second last day of the FDP, and I'm going to discuss correlation and regression today. So just a minute, I am sharing my screen. I hope my screen is visible and PPTs are now
Yes, ma'am.
Yes,
shared.
ma'am, they're
Yes,
visible.
yes. Thank you so much, everyone, for confirming. So now today I'm going to discuss firstly correlation, and afterwards we will discuss the regression. So the agenda for the day, I'm going to discuss correlation, its types, assumptions of correlation. Then lastly, I'll discuss regression and its assumption. And then we will proceed for the SPSS to see how we can perform these two tests in SPSS. So talking about correlation, I think we all have heard the term correlation, and we are knowing this thing that correlation meaning is we are interested in finding the relationship between two variables. The name itself indicating as the meaning. So generally, correlation is very important statistical tool in statistics. Whenever we are talking about correlation, we are interested to find the relatedness between the two variables, that whether the two variables are related to each other or not. So correlation is a kind of building block of these statistics, because in many of the studies, when we are performing some advanced statistical tool, generally we are getting output. In the output section, we are getting the value of correlation. So generally correlation is very helpful to find the relationship between two or more variables. Now, talking about correlation, so I can say that correlation will help us to find the extent of relationship between two variables. Means up to what extent two variables are correlated to each other. So this way, correlation gives us the strength of relationship between two variables, and also with the help of correlation, we can find the direction of relationship between two variables. So these two things are very important. With the help of correlation, we can find the strength, and second, we can find the direction of relationship. Generally, when we are talking about Pearson's correlation, that means we are interested in finding the linear relationship between two variables. So one example I have quoted in this slide, the example is saying to us that generally when we are putting efforts in our study, we are learning more, because when we are putting efforts, so might be possible we are arranging some more things to get more clarity about the topic. So that way we are learning it fast, or we are learning more. So that way we can say it is a kind of positive correlation. Now, talking about the types of correlation, generally there are various types of correlation, like simple correlation, multiple correlation, positive correlation, negative correlation, linear, non-linear correlation. But when we are talking about the direction, we are interested to understand two types of correlation, that is the positive correlation and negative correlation. So positive correlation meaning is, here you can see, if I say in this particular graph, this is indicating as the positive correlation. That means when I am increasing one variable, the other variable is also increasing. That way we can call it as a positive correlation. So this is known as positive correlation. Second diagram is showing us when we are increasing one variable, other variable is decreasing. That way it is known as negative correlation. And if we are plotting a scatter plot between two variables and we are getting such type of distribution of the data points, so that way we can say there is no correlation between the two variables. Now, as I said about the directions, you can see when I'm increasing x, y is also increasing. When I'm decreasing x, y is also decreasing. So this is known as the positive correlation. Then if I'm increasing x, y is decreasing, and vice versa. So that way it is known as the negative correlation. So two examples I have quoted here: number of hours of study and marks. So here we can say it can be a positive correlation, demand and price. So demand and price is indicating as the negative correlation, because when we are increasing price, generally demand gets decreased. So that way the direction of change in these two variables is vice versa. It is known as negative type of correlation. Now, coefficient of correlation. So as I said, generally whenever we are talking about the correlation and we are interested in find the strength of correlation between two variables, we are using Pearson's coefficient of correlation. So coefficient meaning is it is the particular value which would range between certain limits. So I think everyone is knowing this thing, that the correlation value ranges in between -1 to +1. So that way the coefficient can be one more thing. The coefficient meaning is that the correlation is unit free. That means there is no value of the correlation. That's why we are calling it as the coefficient of correlation. So here in the table we can see different values or different ranges are mentioned at the left hand side, and according to these ranges interpretation I have mentioned in the right hand side of the table. So when we have calculated R and we are getting the value of R as 0, that means there is no correlation between the two variables. When the value of R lies in between 0 to 0.3, it can be ±0 to ±0.3. So we can call it as a positive or negative correlation. Similarly, when the value of R is lies in between ±0.3 to ±0.5, so we can call it as a average or moderate correlation. When R lies in between -0.5 to ±0.5 to ±0.7, we can call it as the above average correlation. And if R lies in between ±0.7 to ±0.9, we can call it as a high correlation. Similarly, if we are getting the value of R greater than 0.9, so it is an alarming type of condition for some advanced studies, because in that case there would be multi-collinearity among the variables, and in that case you need to be very careful while performing some other statistical tool on such kind of data. Now, the types of variables which we are using for correlation, according to the various types of measurement scale, the correlation can be different, which we can apply on the data on the basis of the measurement scales. So here you can see, if we have both the variables, that is y variable and x variable, or dependent and independent variable. So that way we are knowing, that way we can say if we have measured both the variable on continuous scale, we will go for the Pearson's coefficient of correlation. But when the y variable, that is the dependent variable, is on continuous scale, our independent variable is on ordinal scale, so we will go for the biserial correlation. Then similarly, if your y variable, that is dependent variable, is on continuous scale and your independent variable is on nominal scale, we will go for the point biserial correlation. Then similarly, when the variable is, that is y, on the ordinal scale, means dependent variable is on ordinal scale, and then I'm talking about coming to the next variable, that is the x variable, which is also we have measured on the ordinal scale. Means when both the variable we have measured on ordinal scale, we will apply Spearman's rank correlation or tetrachronic correlation we can apply. This is the other name. Now, talking about when the y variable, dependent variable, is on ordinal scale and the x variable, independent variable, is on nominal scale, we will go for the rank biserial correlation. Lastly, when we have both the variables on nominal scale, y and x, both we have measured on the nominal scale, we will go for the coefficient of phi or lambda test we can perform here on the basis of measurement of scales. So this is the means this particular different types of correlation I have taken from this Calkins study, which were reported in the year 2005. So these are the different correlation we can choose according to the various kind of measurement scales. Now, talking about the assumptions of correlation. So you can see there are 5 assumptions of correlation. The very first one, both independent and dependent variables should be quantitative. Quantitative meaning is it should be on continuous scale or it should be measured on interval or ratio scale. Then talking about linearity. So there should be linear correlation between both the variables, that is x and y. Then third one is the absence of outliers. That means in both the variables there should no outlier should be existing between both the variables. But again, if we want to perform regression analysis with the help of the output of the correlations, in that case we are already knowing which variable is dependent or which variable is independent. In that case, we will generally bother about the dependent variable, that it should not carry any outlier. Then talking about the normality. So again, according to the further study, you need to decide upon which variable is dependent. So according to that, you need to check whether that dependent variable is normally distributed or not. Generally, it is said that to meet the normality assumptions, we need to have generally 30 observations or the 30 pair of observations of both the variables. So generally, minimum requirement of correlation is 30 observations if we want to achieve the normality in the data. So these are the certain assumptions which our data must abide by to perform correlation. So now, importance of correlation is this, that correlation is helps to explain the variability. Generally, when we will get the output of our regression, so in regression we are getting the value of R and value of R, that is correlation, and along with the value of correlation we are also getting the R square. So with the help of R square, we will understand that how much of the dependent variable is explained by the independent variable. Then that could be the base of causation but does not guarantee causation. So the meaning of this is that whenever we are going for correlation, that means we cannot say that correlation is giving us the cause and effect type of relationship between two variables. With the help of correlation, we can only find the correlation or the relationship between two variables. If we are interested to know that which variable is cause variable and which variable is effect variable, or which variable is impacting the other variable, in that case we will go for the regression. In that case, correlation will not help us. Generally talking about the manual calculation, as on each and every day I have discussed about the manual calculation. So here you can see there are various formulas available. With the help of that, we can calculate the small r value, that is the coefficient of correlation value. So these are the three different ways to calculate the coefficient of correlation. This is the table which I have showed you. If we want to perform the, suppose this particular formula. So to get this formula, if you have two variables, you can multiply them. You can take the square of individual variable, and that way you can supply all the values in the formula and you can calculate the R. Now, talking about how we can perform correlation in SPSS. So you can see, we can go to the analyze menu, we can select correlate, and then we can choose bivariate to perform coefficient of correlation on the data available with us. So I think I can directly move now for correlation, and then I'll come back and discuss about the regression. So for the, yes, sir.
Ma'am, before that, I had two queries I wanted to ask regarding the theoretical explanation that you've given. So, ma'am, firstly, you talked about multicollinearity, right? When we say that the value of R is greater than 0.9. So, ma'am, can you just tell us what multicollinearity actually is? I mean, I've heard this term a million times, but then I do not know the exact meaning of it. I mean, many researchers and statisticians talk about that there should be multicollinearity, but then I do not understand this term much clearly.
Okay. So, sir, I'll explain you. Multicollinearity meaning is generally when we are going for the multiple type of linear regression, in that case, we will check the multicollinearity. That means our independent variable should not be highly correlated. If our independent variables are highly correlated, that means they have their own relationship among the variables, and that way the relationship between dependent and independent variable may affect. It is known as the multicollinearity. Similarly, when we are performing factor analysis, I think you have heard about the factor analysis also. I think you are knowing the many things. So you have heard about the factor analysis also. So in factor analysis, generally what we have certain statements or we have certain items. So whenever we are certain items and we want to perform factor analysis on those items, so firstly you need to also check whether there is correlation among those items or not. So that correlation should be moderate. It should not be greater than 0.9. If it is greater than 0.9, that means items are highly correlated to each other. That means they I can say that respondents are not understanding, or they are understanding both the statements are almost similar. That's why they are giving their responses very close to each other. So that way it is indicating, in that case you need to drop either of the statement, and that way we can reduce the value of coefficient of correlation, and that way we can say we have overcome to the overcome to the multicollinearity. So, I think, sir, you got the answer. Is it
Yes,
clear?
ma'am.
Is it
Yes,
clear now?
it is. Yes, it is clear. And ma'am, my second question is that you talked about the positive and negative correlation, in which you said that in positive, both the variables move to the upward direction, and in the negative, both move to the downward direction, right?
No, no,
So
no, no, no,
can
no, no, sir. The situation is that, let me show you just a minute.
no, I mean in positive, when one variable is increasing, the other is also increasing, and in
Huh.
negative, one when the one increases, the other decreases, right?
Yes, yes, yes,
Yeah.
yes, correct.
So, ma'am, then can we classify them under linear correlation also? I mean, I was confused with that. If you could please help me.
Sir, we can say, but in linear correlation, generally the meaning is the proportion of change would be same. That means if I say, if I'm increasing one variable by 1 unit, and the similar proportion change is occurring in the second variable, and that way we can say it is a linear correlation. When proportion of change is same, it is known as linear correlation.
Thank you, ma'am. Got the answer.
Okay, sir. So I think now I can move to the SPSS, right? So everyone, please open your worksheet here in the SPSS. Go to the file menu, then open and select data. And wherever you have kept your file, give the location of that file and select your file and click on open. So I have shared you a correlation file. You need to import that data in SPSS. In that there are two columns, reading time and TV watch time, right?
Yes, ma'am.
Yes. Now for the similar data set, I have shared here the questionnaire along, I have shared here the case along with all of you. You can please read it. I hope it is clearly visible.
Yes, ma'am.
Yes. Done.
Yes, ma'am.
Yes, ma'am.
So I think it is quite clear that the student Leela is very much inquisitive to know this thing, that the reading of books is, or is there any correlation between the reading time of books and the watching time of the television. So for the purpose, this data was collected by her. We have used the same data to calculate the correlation and help her out whether there is any correlation or not in between these two variables. So for the purpose, we have taken this particular data here in SPSS. Now, according to the assumptions of correlation, the very first one is the variables should be on, if we are going for the Pearson's coefficient of correlation. So variable should be on which scale?
Continuous.
So here you can see reading time and TV watch time, both the variables are on continuous scale. So this was the first assumption. Then second assumption was, yes, we need to test the collinearity, absence of outliers and normality parameter we need to check here. So now for checking the linearity between these two variables, what you need to do, you can go to the graphs, then go to the legacy dialogs and then select here the scatter oblique dot. Again, I am repeating, to check the linearity, go to the graphs menu, then select legacy dialogs and then select scatter oblique dot. Done, everyone?
Yes, ma'am.
Yes. So once you are clicking on scatter oblique dot, it is giving you the dialog box. From this dialog box, you need to go with the simple scatter type of graph. So that is the by default option selected by the SPSS. You can click on that and here click on define button. After clicking on define button, simple scatter plot box will come in front of you. Here we have two variables, reading time and watch time. Everyone is getting it?
Yes, ma'am.
Yes,
Yes.
ma'am.
So now you need to decide upon whether the reading time and watch time. Can anyone tell me which variable we can take as a on y-axis and which variable we can take on the x-axis?
We can go for reading time on the X and the TV watch time on the Y.
So can you give me the
Opposite.
reason?
Okay, I'm sorry. Going by your statement, you firstly talked about a new television show about which the discussion was being held, right? So I think taking that particular thing to be the independent variable, the TV watch time should be on the X and the other one should be on the Y. Now I had some clarity. I hope I'm right.
Okay. Can anyone tell me? I think Gaurav sir was giving me answer, right?
Yes, ma'am.
Yes. So can anyone tell me whatever answer is given by Gaurav sir, was it correct or not? Yes.
I think he is correct.
Yes. So that means we need to take TV watch time on which axis? Y or X?
X-axis.
Sorry?
On x-axis.
On x-axis. Very good. And reading time on y-axis. Right? Now, after shifting your variables into the respective y-axis and x-axis boxes, you only need to click on OK to generate the scatter plot. Once you will click on OK, the scatter plot is coming in front of you. I think our output is visible to everyone, right?
Yes, ma'am, it is visible, ma'am. I have a doubt. X-axis is for dependent and y-axis is for independent.
Y is for dependent, ma'am. X is for independent.
Okay, ma'am.
Okay. So here you can see we have ready with the scatter plot and that is coming in the output window of SPSS. Now here I think with the graph, it is quite difficult for us to understand whether there is linearity among these two variables or not, between these two variables or not. So for that you need to fit a line here. You need to fit a total line here. So for that, what you need to do, you need to just double click on the area of this particular scatter plot. So double click on this. You will double click, you will be landed onto the chart editor dialog box. So I hope everyone is with me and we are on the chart editor now, right?
Yes, ma'am.
Yes. So here in the lower ribbon, you can find this particular symbol or icon which on which I am rotating my mouse. It is showing you the fit line at total. Everyone, yes, it is clearly visible or not? Visible? May I click on this? Yes. So you can click on this. Once you will click on this, you would be landed to the next box. This is the properties box, and that way what you need to do now, you need to only close this because already you can see the line is available here, right? Everyone got the line?
Yes, ma'am.
Now,
Yes, ma'am.
yeah. Now what you can do, you can close the chart editor because already the line is fitted here in your scatter plot. So you can see the line is what? It is showing us that it is a linear kind of relation. We are getting the straight line, right? And the data points are, although we can say because we have very less data points, approximately how much data we have? Can anyone tell me? I forgot. I think 70 observations we have, right? So that way might be possible. That way we are not much clear about the linearity, but with the line we can say that there is linearity maintained among the two variables, reading time variable and watch time, TV watch time variable. Got it? One thing is clear.
Ma'am, now there are three things that come to my mind when I'm seeing this graph.
Yes,
The firstly, like obviously you have told us, that we need to fit in a line in this graph. Otherwise, if I see and I do not know this line concept, I would conclude that this might not have any correlation because they are scattered onto different. The points are scattered in a different manner, right?
Yeah,
And
yeah.
And secondly, my question is that, ma'am, what was the reason for which we had fitted the line in this graph?
Sir, generally, whenever we are talking about correlation, so with the help of this fit line, we would be able to say this thing, or we would be able to conclude this thing, that there is a linearity among the variables or not. So for the purpose, we have gone to the scatter plot. We have drawn here a scatter plot, and then we have fitted this line. So with the help of this line, as I again said this thing, that data points are very less. We have only data set of 17. The sample size is only 17. So might be, again I'm repeating the thing, may be possible that why we are not able to clearly say this thing, that linearity is maintained among these or between these two variables or not. It is quite difficult for us to say this thing, but somehow we can say that we are getting a straight line, although it is in a decreasing order, or we can say maybe possible the variable will have the negative correlation, right? Because the line is in the decreasing fashion, right? So that way we can say might be possible that these two variables are carrying the negative correlation, and on the basis of this fitted line we can say possibly there can be a linear, or the linearity can be maintained between the two variables, but still, as I said, due to the lack of observation, we cannot 100% sure that linearity is maintained by those two variables or not. Got it, sir?
Yes, ma'am, I'm clear. So basically, this line is introduced to check the linearity between
Linearity between the two variables. And one more thing, generally, as I said, when I was talking about the assumptions of correlation, I said generally we need to have approximate 30 pair of observations. So here I think we have only 17 because the data is created by me. So that's why there might be problem and the data is less. Got my point? Maybe when
Yes,
we are increasing the data, and that way might be possible the linearity can be achieved in an accurate manner.
fine, ma'am. Thank you.
Okay, sir. So I think we can move. Yes.
I would also like to ask something. Ma'am, here you're saying that we don't have clarity, right? And so this way, the points which are going very far from the line, are these, will these be treated as outliers?
No, these are not outliers, ma'am. These are not for checking the outliers. We need to go to the box plot. These are not the outliers. Means what these points are? These are the data points, or these are the TV watch time against to the reading time. Means for first observation, what is the second? For the first TV watch time, what is the respective reading time? So against these two things, these particular dots you can see. That way this scatter plot is designed, and on the basis of average value this fitted line was generated by SPSS.
Right, ma'am, right.
Got it, ma'am?
Ma'am, hello, ma'am.
Yes, ma'am.
I have a question. Means, can you have any measure for deciding the linearity between two variables? Means here, yeah, we can decide from the graph. Can you have? Can we have such any value? Means like a p, if p is less than 0.05, we can say significant result. So like
Ma'am,
that.
as per my knowledge, in correlation, I think we are generally checking with the help of a scatter plot. But in regression, when we will go for regression, so maybe you have performed regression with SPSS. So we will get one table there, and the name of table is ANOVA table. If you have, right? So in ANOVA table, if the significant value is less than 0.05, if we are testing a regression on the 5% level of significance, so in that way, with the help of ANOVA table, you can conclude there that these or the linearity is maintained among the variables we have taken in the regression. But in correlation, anyone is saying something? Okay, so in correlation, we are generally using a scatter plot to check the linearity among two variables. So I hope you people have, we have discussed a lot on this particular thing, and you have got a little bit clarity about this linearity concept in the correlation. So now we are yes, any question?
No, ma'am. Thank you.
Okay, most welcome, ma'am. Okay, so now we will go to check the outliers in the variables. So now we have two variables. So in two variables, this is our as the TV watch time we have taken on the x-axis. So that way we are bothered about the outliers in the reading time. So we will generally check the outliers of our dependent variables, that is for reading time. But if you want to check outlier in both the variables, that also you can do. So for that, I'm going to again graphs, legacy dialogues, and I'm selecting here box plot. Simple box plot, you can see here, first option is simple box plot. I have selected that and I'm clicking on define. Do I need to repeat the process where how I have landed on this particular box? Go to the graphs, then legacy options, and then select box plot. And in the box plot dialog box, you need to only select simple. Everyone have got, right? Got it, everyone?
Ma'am.
Yes. I'm clicking on define. So now here is the reading time. I am selecting my variable reading time, shifting it to the variable box. So as this is our dependent variable, apart from that, you do not need to transfer anything here. You can go to the, just a minute. I think it will create problem for us. Then you can shift your second variable, that is TV watch time, in the category axis, and then you can click on OK. I think this is not the correct way. It is not giving us graph. You can do one thing. You can go to the analyze and can go to the descriptive statistics and then go to the explore. Means the similar fashion which we have done to get the outliers in the variable which we have performed in the previous days. You can go with that. Go to the analyze menu, select descriptive statistics and select explore. And then you can shift your variable reading time to the dependent list box. You can go to the plots. Here you can select the already factor labels together are selected and we are bothering about the outliers. So accept this option. We will not go with anything else and we can press here continue and then OK. So you can see reading time box plot is available for us and it is showing there is no outlier available. Got it?
Yes, ma'am.
And for normality, if I want to say something about the normality of the reading time variable, so with the help of this box plot, we can say that the size of the whiskers are almost similar, but the middle line is not exactly at the middle of the box. So that way might be there can be some deviation from the normality, but still the whisker size is approximately similar. So maybe we can say that the reading time is normally distributed. Or to check the normality with the help of Shapiro-Wilks test, again you can go to the explore and then in plot you can just select here normality plots with test and can press continue and then OK. So the similar way we have done yesterday. So here you can see the QQ plot is coming and it is saying that the data points are going along with this standard line. Approximately they are, because there is very slight deviation, means few of the points are not falling on the standard line. So that way we can say that approximately normally distributed variable we have, that is the reading time. Now with the help of Shapiro-Wilks test. So,
ma'am, can you please repeat the step once again, how you calculated it?
Yes, sir. Go to the explore option as we have went. Go to the analyze menu, descriptive statistics and select explore. Done, sir? Do
yes,
I need to show you again?
No, it's okay. Fine.
Okay. Then click here on the plots and in the plots, just click on the normality plots with test, means check this particular checkbox. Done. And then you can press continue and then you can press OK to generate the or to produce the output. So output is produced by SPSS. So in this particular output, as the sample size is very small, so we are reporting Shapiro-Wilks test, and for Shapiro-Wilks test, the significant value is far more than 0.05. So that way we are going with the null hypothesis of Shapiro-Wilks test, which is stating us that the variable is normally distributed. Everyone, it is clear?
Yes, ma'am.
Yes,
So means, so yeah, thank you everyone. So we can say that yes, according to this particular Shapiro-Wilks test, we can say that the variable is meeting with the normality assumption of the correlation. So now we are ready. We have checked our assumptions. Now you can go to the analyze menu, can select correlate and then go to the bivariate. Again, I'm repeating, go to the analyze menu, then select correlate and then go to the bivariate option and then click. So may I click on this? Everyone is ready? Yes?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes. Now you have two variables in your file. Both you can see at the left hand side. And for correlation, we need to have at least two variables. We have those variables. We are shifting those variables with the help of this arrow in the variables box. Now you can see in options, it is showing us mean and standard deviation if you want to calculate for your variables. So that you can click here if you want to calculate cross product deviation and covariances. So actually, we do not need to have, we do not need to calculate these two things. So that's way what we are going with the by default option and we are clicking on continue. And then in the lower of this particular box, you can see three things are there. First thing is coefficient of correlation. Pearson is available, Kendall's tau B is available, and Spearman rank is available. So as our variable are on continuous scale and almost all the assumptions are met by our variable, so we are going with the Pearson's coefficient of correlation. It is the by default option given by SPSS. Now talking about test of significance. So by default, it is giving us the results or the significance value we will get for the two-tailed test. If you want to check for one-tailed test, you can click on that. But generally, correlation hypothesis, generally we are checking for two-tailed test. So we will go with the by default option. Now you can check you can see the last checkbox which is already by default checked by SPSS. It is flag significant correlation. So that means if the correlation value is significant, so we will get the asterisk sign. Flag means we will get the asterisk sign, and that way it would be written in the output whether the significant correlation is there in the variables or not. So with the help of this, we will get this particular thing in the SPSS. So these means only shifting your variable from left box to right box. You do not need to do anything here. You need to only press OK here to generate the outputs. So once I will click on OK, you would be able to see that we are getting the output in the output window of SPSS. And here the Pearson's correlation between reading time and TV watch time is minus 0.494, and its significant value for two-tailed test is 0.044. So that way we can compare this value with the 0.05 and we can conclude this value is less than to the 0.05. That's way we do not have sufficient evidences to accept the null hypothesis. So we are going with the alternative hypothesis. And here a hypothesis can be there is a significant relationship between the reading time and TV watch time. Got it, everyone?
Yes, ma'am.
Yes, ma'am.
And one more thing you can see here, as the correlation or the coefficient of correlation value is negative. So that way we can say if we are increasing our reading time, maybe the TV watch time can decrease. Got it? Or vice versa. Clear, everyone?
So, ma'am, that way we can say that there is a negative correlation between both.
Yes, between both, but this correlation is means it is not a strong correlation. It is moderate correlation between the two variables. Negatively moderate correlation between the reading time and TV watch time. Okay, sir, everyone has got this?
Yes, ma'am, clear. Thank you.
So here you can see flag meaning, which I have told you, the by default option of the particular correlation dialog box. Flag meaning if it is significant, this star is coming here. So that's why it is this is the I need to tell you what is the meaning of flag. So it is showing you correlation is significant at 5% level of significance for two-tailed test. So this is the description, or this is the explanation of correlation from my end. I think any query is here, or may I move for the regression directly now?
The
inference is that there is a negative correlation between the two variables.
Yes, ma'am. We can say that there is a significant moderate negative correlation between the two variables, reading time and TV watch time.
Okay. And ma'am, one more thing. See, ma'am, I have a confusion between dependent and independent variables because in this case we have made the reading time as a independent variable and the TV watching time as a dependent variable. So it can be vice versa also, ma'am.
Ma'am, yeah, it can be. Again, I'll repeat one thing. I maybe in the previous days, maybe I have mentioned this thing. If not, so I'm saying this thing. Generally, it is totally depending upon our objective, which what objective we have framed, and according to our objective, we will frame our hypothesis also, right? So this is our assumption, which variable we are taking as a dependent, which variable we are taking as independent. And second thing, whenever we are talking about correlation, so in correlation, generally we are not bothering about the dependent and independent variable. But when we are on the same data, if you are performing some advanced statistical tool, in that case, you need to check which variable you are taking as a dependent variable, because for that you need to check outlier assumption and normality assumption. Got it, ma'am?
Yes, ma'am. Yes.
So I think now I
Ma'am, may I
move.
tell it?
Yes.
May I tell
Yes,
it the
yes,
other
sir.
way around if you allow me?
Yes, definitely, sir.
So what my interpretation was, seeing the statement, in the statement it was told that there is a new TV program, right, in which many people are seeing that. So we need to check the effect of the TV program on the reading time, because of watching more TV. The reading time is being affected. So the variable which is being affected, I can say that is a dependent variable, and because of which it is being affected, that can be the independent variable. So am I right in my interpretation, ma'am? If I'm wrong,
You
you may
can
please correct me.
you can say, sir, it is like so also, but might be possible many of the student, maybe they are not interested in reading and they are not taking books from the library also. So maybe they are not bothering about the reading time, or that way we can say this thing also. So again, I will mention one thing. Yes, you are correct in your way. If you are understanding, or you are making your assumption, or you are making your hypothesis in that manner, so you are very correct. But if some other person want to make TV watch time as a dependent variable, maybe they can take. Okay, because it is totally a independent thing we are doing. We cannot, what I can say, we cannot interfere in anyone's thing. So if the person is finding, maybe in any of the researches, they have finding TV watch time as a dependent variable, and they are giving the sufficient support for that particular thing, they can take that also. But I think you are correct, because yes, exactly meaning of the case which I have showed to everyone here, you people have read, the meaning of that is that only. So according to that, we can take reading time as a dependent variable. Okay, sir?
Result interpretation in single line will be, can you please repeat?
Yes, we can say at the looking at the significant value, we can conclude this thing here, that the significant value is less than 0.05. So that way we are going with the alternative hypothesis, and we are concluding this thing, that there is a significant moderate negative correlation between reading time and TV watch time.
Okay, ma'am. So we will write that there is a significant, moderate, and negative correlation between both.
Yes.
Thank you.
Okay, ma'am. So I think, may I move now for regression, right?
Yes, ma'am.
Yeah,
Yes,
thank you, sir. Yes. So we are here with the regression. As I said, till correlation, we are not bothered about the causation or cause and effect type of relationship. But if we are interested to find cause and effect type of relationship, if we want to see which variable is impacting the other variable, so that means we want to go, or we want to apply on the regression statistical tool on such kind of data whenever we want to find the cause and effect relationship, or whenever we want to find the impact of one variable on other. So this is the primary.
Sorry to interrupt you, ma'am.
Yes.
Ma'am, can you explain once again how do you write the interpretation for correlation, ma'am? Because your voice is not audible for me.
Okay. So you can write, ma'am. There is. Are you writing? Do I need to? Hello.
Yes, ma'am. Yes, ma'am. Tell me, ma'am.
Yeah. There is significant,
significant,
moderate,
moderate,
negative correlation between reading time and TV watch time?
So, yes, ma'am.
Done?
Hello,
Okay.
yes, ma'am. Yes. Thank you.
Okay, okay, fine. So now we are coming to the regression. As I just said, whenever we are interested in cause and effect relationship, whenever we want to see the impact of one variable on other, we are going for the regression analysis. So regression analysis is generally it is known as generally simple linear regression when we are having two variables. One is dependent variable and one is independent variable. So that way it is known as simple linear regression. But when we have more than two variables, one dependent and more than one independent variable, in that case it is known as multiple linear regression. So regression helps us to establish the cause and effect relationship when we presume two variables are linearly related to each other. And as I have just mentioned, in the output of SPSS we are getting the value of ANOVA, and that will ascertain us that whether there is linearity between two variables or not. So the linear relationship means we increase independent variable with certain amount, the dependent variable will also increase with the fixed amount. This is the meaning of linear relationship. Now, if we can quantify for every unit increase in independent variable, what would be the increase or decrease in the dependent variable? That means in that way, we get the linear relationship between the two variables. So we use the linear regression when we are interested in studying the effect of one independent variable on one dependent variable. So again, you need to be very much attentive here. You need to see, because I'm talking about the simple linear regression. So in simple linear regression, we will have one dependent variable and one independent variable, and we are interested to find the impact or effect of independent variable on dependent variable. So if we have more than one independent variable, I just said in that case, we will go for the multiple linear regression and not for the simple linear regression. Now, the hypothesis which we can formulate, or in for regression, which kind of hypothesis we can formulate. So generally the hypothesis can be, these are the four ways of defining or formulating your hypothesis. The very first one is saying, if we have two variables, advertisement and sales, so I can say advertisement is not related to sales. Second way, I can say that there is no significant relationship between advertisement and sales. Or I can say there is no significant effect of advertisement on sales. And lastly, I can say there is no significant influence of advertisement on sales. I think last two hypotheses are very much clear, because from the last two hypotheses, we can clearly say which variable is dependent variable and which variable is independent. So after reading these last two hypotheses, can anyone of you tell me which particular variable we are taking here as an independent and which variable we are taking as a dependent?
Ma'am, sales is
Advertisement
dependent,
and
advertisement is independent.
Yes, very good, very correct, ma'am. Advertisement we are taking here as an independent variable, and sales we are taking here as a dependent variable. So generally, last two hypotheses are very much clear to tell us that generally we are finding the impact of one variable on other, or the impact of independent variable on dependent variable. So this way we are interested in applying regression to test such type of hypothesis. Now, talking about the assumptions of regression. So there are 8 assumptions, as you can see here in the slide. Now I'm reading all the assumptions one by one, and then we will see how we can test them. So you can see first assumption is, for simple linear regression, both the variables should be measured on either interval scale or on ratio scale. Or I can say both the variables, dependent and independent, should be measured on continuous scale. This is the first assumption. Second, there needs to be a linear relationship between the two variables. So this is we will check with the help of output of regression in SPSS. Second, there should be no significant outliers in the dependent variable. Then the residuals of the regression should follow a normal distribution that we will check with the PP plot. Then there should be absence of multicollinearity that we will check with the help of VIF, variance influence factor. Then the values of residuals should be dependent, should be independent. That means the residual values should not be independent, or they should not influence each other. So that we will check with the help of Durbin-Watson value. Then the residuals needs to show the homoscedasticity or the homogeneity of variances or equality of variances. That we will see with the help of a scatter plot. And lastly, there are no influential cases biasing the model. Means with the help of regression, we are generally interested to generate or produce a model or to fit a model between the variables. So in that particular case, model should not be influenced by the specific case we are taking in the data set. If particular case is impacting your model, that way you need to drop that particular case from your study. So that we will check with the help of Cook's distance value that we will apply in the SPSS. So these are the 8 assumptions which we are using to test our data, that whether data is fit for the simple linear regression or not. Now, as I just have taken one particular name, that is the residuals. You have seen here, it is mentioned in the previous slide, that is the assumptions of regression slide. Now the meaning of residual is what? Generally residuals are termed as error. So what is the error? It is the difference between the actual and the expected value. So this is the difference, means whatever value I have predicted with the help of regression model and what is the actual value of that particular variable on the different period of time. If there is very less difference, so that way we can say error term is less. But the difference is if large, so that way we will say that if there is a large error term is associated with the model, and that way it is definitely impacting our model, and that way we can say that model is not a good fit and it is not correctly predicting the value of our dependent variable. So this is the meaning of residuals. Now talking about when we will check the whether the homogeneity of variance is maintained by our variable or not. So you can see with the help of a scatter plot, if we are getting such type of scatter plot. So at the left hand side, you can see this type of distribution of data we are getting for our variable. So that is showing us that our variable is homoscedastic. That means the homogeneity of variance is maintained by our data. Homogeneity of variance meaning is here that our residuals variance is similar or almost similar over the period of time. Now talking about heteroscedastic data means if your data or distribution of residuals is showing this kind of shape, funnel type of shape you are getting, or cone type of shape you are getting, so that way you can say this thing that your data is not meeting the homoscedasticity or the homogeneity of variance assumption of the regression. So that you need to be very much clear. You need to check on with the help of these particular graphs which we will plot in the regression, that is the scatter plot. So I think it is clear. If we are getting this kind of distribution, we will say that homogeneity of variance is maintained by residuals. If we are getting the cone shape, means all the residual values are going somewhere, means in a particular point they are moving. So that way we are say this thing, this is a kind of cone, or we can say this is a kind of funnel shape we are getting here, and we can say that the residuals are not following the homogeneity of variance assumption of regression. So I think I am clear on this.
Yes, ma'am.
Yes. Now one more way, again you can see if you are getting this kind of distribution of residuals, you can say that the residuals are following the homoscedasticity, or else you can see, or you can say that the residuals are not following the homoscedasticity, or they are going, or they are showing the heteroscedasticity in the output. Now talking about the regression line. So how we will apply the regression SPSS in the SPSS firstly. So you can see we will go to the analyze menu, we will go to the regression, and we will select the linear, and we will keep the method as enter only. This is the equation we are generally writing, that is y equals to a plus bx plus e. So y is the dependent variable, a is your intercept, b is the slope, x is the independent variable, and e is your error term. So this error term or the residual value should be less if we want to fit a good model with the help of regression. So now I think we can proceed to perform regression in SPSS. So now please open the second file which I have given you. I think advertisement and sales, right? Everyone has imported the data file here in SPSS?
Yes, ma'am.
Yes, thank you everyone. So now, firstly, the first assumption we are checking here that the variable should be on continuous scale. So we can see here advertisement and sales both are on the continuous scale. For this particular thing, we can take the case as there is a company who is investing huge in the advertisement and they want to check here whether the advertisement done or whether the expenditure we are bearing in the advertisement, it is impacting their sales or not. So this is the case which we are discussing here with the help of this particular data set, and we will see whether the company is whatever hope they are carrying, whether this data is meeting that or not, right? So now firstly, first assumption we have already checked. Now for checking the, I think what was the next assumption? Can anyone tell me? I forgot the next assumption was linear relationship, yes. So for checking the linear relationship, again, what you need to go, you need to do, you need to go to the graphs. You can go to the legacy dialogues and you can go to the scatter oblique dot option. You can select here. So with this, you need to simply select here the simple scatter and you need to click on define. Now you are here on the simple scatter plot dialog box. You can shift your independent variable on the x-axis and dependent variable on the y-axis. I think done.
Yes, ma'am.
Yes, and in the hypothesis only we have seen that sales is our dependent variable we are taking on y-axis. So I have shifted sales on y-axis and advertisement we have shifted on x-axis. Now you can click on OK. Once you will click on OK, you would be able to get the output. I think everyone is getting it, right?
Yes, ma'am.
Yes. So I think from this particular graph, we can say, yes, it is showing the linearity, right? Gaurav sir, I think you
Yes,
would be agree with me, right?
Yes, ma'am.
Yeah. Now to fit a line, because a line will give us the clear picture. So again, you need to double click on this. The chart editor will open. You need to just click on the fit line at total. You can just click on this and then you can close this properties box and also the chart editor box. And that way you would be landed to your output window and it has fitted a straight line among the data points. And on the basis of this straight line, we can say, yes, there is linearity in the data, right? We can say it is showing upward type of direction.
Yes, ma'am.
Yeah. So we can say that linearity assumption is met by the two variables we have taken for regression study. So second assumption we have checked. Next one is for the remaining assumption. Yes. For outliers also, you need to be here only. So for outliers, what you need to do, you can go to the explore and you can shift your sales into the dependent list box. In the plots, you can click on this, and I'm also selecting here normality plots with test so that we can check whether the variable is normally distributed or not. So you can click on normality plots with test also, and by default you can go with the box plot option and you can press continue and then OK to generate output. So with the help of the significant value of Shapiro-Wilks test, can we conclude that the variable is normally distributed or not? What we can conclude with the help of Shapiro-Wilks test? Can anyone tell me?
Non, not normally distributed.
Not normal. Yes, very good.
Alternative.
Yes.
Ma'am, can you please scroll down your screen? I need to see that. I mean, in my case, two diagrams are produced. Yeah, these two.
Yeah, sir, every time we are getting two diagrams, I think maybe you have not scrolled down, or you have not pay attention in the previous times when we have done this. One is normal QQ plot and second one is the trend normal QQ plot. So you need to only report this normal QQ plot.
So this is of relevance to us, not the trended one.
Yeah, it is not relevant. You need to report this only to check the normality of your variable. So with the help of this particular graph, again, you can see that the data points are not falling on this particular line. They are deviating from the line. So might be possible it is again giving us clue that the variable is not normally distributed now. Outliers, you can see here outliers is not there in the variable, right? There is no outlier, no circle or asterisk we are getting here, right?
Yes, ma'am.
Yeah. So that means outlier assumption we have checked, but normality we have also checked. But as you can as I can come here in the slide, you can see we have not mentioned about the normality of our variable. We have mentioned the normality of our residuals, right? Everyone, yes?
Yes.
Please
Yes,
read.
ma'am.
Yes. So that's why we are not bothering about the normality of our variable, because we are bothering about the normality of our residuals, and residuals we have not calculated yet, that we will get with the help of regression outputs. That's why you are not bothering about that. We have only checked here the outliers. So two assumptions we have checked. Now we will go to the direct regression, and remaining all the whatever assumptions we are carrying or we want to check for the variables, we will directly check with the help of the output of the regression. So now what you need to do, you need to go to the analyze menu, then you need to go to the regression, and then you need to select linear. Again, I'm repeating, go to the analyze menu, then select regression, and then you need to select linear from the subsequent box. Done. May I press linear? Click. May I press here?
Yes, ma'am.
Yeah. So I'm clicking on this. So I think output is generated. Sorry, the dialog box is coming here for the linear regression. Now, what you need to do, as it is quite clear to us that sales is a dependent variable, we are shifting it to the dependent box. Advertisement is independent variable, we are shifting it to the independent box. And that method is already, it is by default enter, although some other methods are also available, but enter is always give us the better results. It is generally mentioned in the literature. So we are going with the by default method, that is enter. Now what you need to do, you need to click on the very first button, statistics. Once you will click on that, you can check here two options are already, or two checkbox are already checked by the SPSS. These are the by default suggestions by the SPSS. We will keep these two, and apart from that you can click on the descriptives, and you can click on the collinearity diagnostics. This is the two things you have clicked, and from the lower section you can click on Durbin-Watson. You can see here it is giving you for residuals, right?
Okay, ma'am.
Yes. And as you can see, as I have written in the slides also, that the values of residuals should be independent. So for checking the independency of our residuals, we are going with the value of Durbin-Watson. So this is all you need to select here from the statistics button. After that, you can press on continue. Done, everyone?
Ma'am, can you please repeat?
Yes. I am resetting everything, ma'am. Now you can see two variables are lifted at the left hand side. Advertisement is our independent variable. You can shift it to the independent box. Sales is our dependent variable. You can shift it to the dependent box. Now after that, you can see enter method is already by default selected by SPSS. You can go to the statistics. In a statistic button, in the statistics box, you can see two options or two checkboxes are already checked by SPSS. So we will go with these two, and along with these two, you need to click on descriptives, and you need to click on collinearity diagnostics. And then for residuals, whether the residuals are independent to each other or not, you need to click on the Durbin-Watson. So this is all you need to select here. Done, everyone? Ma'am, you are done?
Yes, ma'am. Thank you.
Welcome, ma'am. Now you can press continue here, and we can go to the next button, that is plots. In the plots, as you need to check the normality of your residuals. So what you need to do? You need to select your Z predicted values and shift it to the Z predicted value. You need to shift here on the x-axis. No, Z predicted value you need to shift here on the y-axis. Residuals value you need to shift here on the x-axis. Then everyone?
Yes, ma'am.
Ma'am, can you repeat again, please?
From where, ma'am?
Ma'am, opening this dialog box, I'm sorry.
Okay. You can click here on the plots button. From here only, ma'am?
Yes, ma'am.
Yes. You can click on the plots button. You would be landed on the plots dialog box. Here we are as according to our assumptions, as we have to check our assumptions also here in the output of regression. So you need to generate the scatter plot. So what we are doing, we are generating our scatter plot for the standardized residual value and the standardized predicted values. Z values, Z predicted value and Z residual values we are taking here. It is clear?
Yes, ma'am.
Everyone, it is clear?
Yes, ma'am.
Yes. So now you are shifting your variable one by one into the dialog box.
Ma'am, you need to share your screen once again.
Screen is not visible.
No,
Yes,
it
ma'am, not
cannot
visible.
show.
No,
ma'am.
Stop presenting.
No, ma'am.
Okay. Just a minute. I think what happened suddenly? It is visible now?
No, ma'am, not yet.
No, ma'am. No, ma'am, not yet.
Okay, just a minute.
Ma'am, you may just refresh it once and you can try again. I believe it
Yeah,
should work
I
out.
think I'm doing, sir. It is visible now?
Yes, ma'am.
ma'am.
Okay. So I think where was I? Here. I think from this I need to tell, right?
Yes, ma'am.
Yes.
Yes.
So now you need to select your residuals. You need to shift your residuals on the y-axis. Predicted value standard. Z predicted you need to shift on the x-axis. Done?
This is one is the residual value and other one is the
Predicted value.
selected value.
No, predicted. Because
It
we
is
are doing the forecasting, ma'am, here with the help of regression. Generally, regression we are using for the forecasting. So we want to predict our dependent variable value. So that way we would be able to get the residuals, right?
okay.
So again, I'm repeating, shift your Z residual in the Z in the Y box and the Z predicted in the X box. Done? Shifted? Everyone?
Yes, ma'am.
Yes.
Yes,
Then
ma'am.
then you can click here on the normal probability plot. For the residual, you need to generate this PP plot. So you need to click on normal probability plot and you can press on continue. So may I press on continue? Everyone?
Okay, ma'am.
Yes. Now, lastly, you need to go to the save button. Click on save. Everyone has clicked on save button? Yes.
Yes, ma'am.
Yes.
Now here you need to click on cooks. In the distances, in the second row, you can see distances boxes there, and you need to click here on the cooks. Done? Yes, everyone?
Yes, ma'am.
Now press continue. And now we are all set to generate outputs. Means from 3 buttons only, we need to do the exercise of performing regression. And we are ready with the all the settings, and we can generate now results by pressing OK here. So I think, may I press OK here? Yes, everyone?
Yes, ma'am.
Ma'am,
Yes,
mine,
ma'am.
ma'am,
Yes.
sorry.
Ma'am, can you repeat once again? Save menu.
Ma'am,
Yes.
when
Yes.
I press continue, the next box is not coming, ma'am.
Next box. Which next box, ma'am?
Well, the final box which you explained for cook.
Just a minute. Just a minute. The save you have clicked, right?
Okay, this after this we have to press the save. Okay, I don't
Yes.
have to press continue. Okay, ma'am.
Yeah,
Okay,
you need
ma'am.
to
Thank you,
press
ma'am.
save. Yes.
Okay,
Then
ma'am.
cooks
Got it.
and then continue. So I think one of the participant was asking me to repeat. From where I need to repeat?
Okay.
I think one ma'am was asking me to repeat. Ma'am, from where I need to repeat?
Yes, ma'am, I got it, ma'am.
Okay. So I am cancelling it because output is already generated. I hope everyone has got the output. Yes.
Yes, ma'am.
Yes. So now
Yes,
you can see, yes, thank you, ma'am. So now you can see the very first table we are getting of the descriptive statistics. In this table, mean and the standard deviation of both the variables are reported along with the sample size or along with the data points for both the variables. So as we are dealing with the regression, we will have two variables. So there should be always same number of observation available for both the variables. So this way you can get the first table, and this is indicating the mean value and standard deviation value for both the variables. Now talking about correlation. So as I think I forgot to mention during when I was discussing through the PPTs, there is one thing. Correlation is the prerequisite of the regression. Means if we want to perform regression, you need to always check the correlation. So as we forget to check, but SPSS is smart enough and he has given us the output of correlation. So here you can see the correlation between the variable sales and advertisement is 0.862, right? Everyone, 0.862
Yes,
is the
ma'am.
yes.
Yes,
And its significant value is what? It is less than 0.05, right? So that way we can conclude here that there is a strong positive, there is a significant strong positive correlation between the sales and advertisement. So this way correlation is maintained between the two variables. So that means these variables are ready for the regression. Now we are going further and we will check here the next.
If a negative will come, we can run regression here.
Yes, there should be positive. It is not like a positive relation should be there. The relation should be significant. So this is significant as per the significant value, right, sir? It is not like
Okay.
might be possible two variables can be negatively correlated. It is not like they will always be positive correlated, right?
Okay, ma'am. Okay, thank you.
Yeah. Now variables entered, for entering the variable, we have used the enter method. Now talking about model summary. So before reporting the model summary and remaining things, firstly, we are moving further and we will see the graph. Everyone, I think you would be able to see the chart here. This chart we need to see here, a scatter plot. Everyone, are you able to see this output at your screen?
Yes, ma'am. Yes.
Yes.
ma'am.
Yes. So as
Ma'am, can you please repeat?
ma'am, from where?
Ma'am, this graph only, basically.
Yeah.
How to arrive at this graph?
Ma'am, you need to just scroll down. Your output window, you need to scroll down.
Okay.
Okay. So here you can see when I have shown you in the slides for homoscedasticity and the heteroscedasticity, I have shown you. So we can say this particular scatter plot is showing us what it is showing us. Can we say the homogeneity of variance is maintained among the residuals? Can we say it?
Yes, ma'am.
Yes. Yes. Because the residuals are approximately randomly distributed and they are not forming the shape of cone or the shape of funnel. So that way we can say the homogeneity of variance is achieved or met by the residuals of this particular data set. Now you can double click on this. After double clicking on this, you need to click on this fit line. I think everyone has double clicked on the area of a scatter plot, right? You are here on the chart editor window. Everyone?
Yes, ma'am.
Yes. So now here at the lower ribbon, you can see fit line at total available. So you need to just click on this particular option, and from this you need to click on this lowest. Done, everyone? Everyone done?
Yes, ma'am.
Now click here on apply, and then you need to close it. Now you can do one thing. The line, I think everyone would be able to see the line on the scatter plot on the chart editor window. Everyone?
Yes, ma'am. Yes.
Now what you can do, you just need to double click on the line. Once you will double click on the line, you would be landed to the again properties window. From this window you need to go to the lines option. Upstairs lines tab you need to select here. Everyone has selected it?
Please can you repeat from the line when you started drawing the line?
Okay. When what you need to do, you need to double click on this particular scatter plot, right? You
Yes,
would
ma'am.
be on the chart editor. You need to click here on this fit at total line. This
Yes, ma'am.
particular option, you need to fit line at total, you need to click. Now you need to be landed on the properties box. Here you need to click on lowest. Done?
Yes.
And then you need to click on apply.
Okay, ma'am.
And then you need to close the window. Done?
Yes, ma'am.
Yeah, I think, am I getting this? I think everyone is getting this type of output, because I think I have applied it 2 times, right? I think you people are not getting this type of line. The shape is,
Yes, ma'am. Yes. Not
shape
getting that type.
is shape is different, or similar shape you people
Yes,
are
ma'am.
getting?
Shape is little bit different.
Yeah, because I have applied it 2 times. Just a minute. I need to perform regression analysis once again. Yeah. So I'm just double clicking on this, going to this fit line at total, selecting here lowest, and then I'm applying it and I'm closing it. Everyone has done this, right? We are getting the shape.
Yes, ma'am.
Yeah. Now you
Yes,
need to double click on this line. Once you will double click, you would be back to the properties box. Here you need to go to the lines tab. Done, everyone?
Yes, ma'am.
Now I am changing the weight of this particular line. I want to make it little more clearly visible, so I am keeping it as 2. You can keep whatever way you want, whatever point you want to select. I am increasing its width, so I have kept it as 2. Now if you want to make it clearly visible, you can select some of the colors which are here. So I have clicked here on red. When I have clicked on this red, you would be able to see in the preview it is showing me red. That means now the color of this line would be red. Okay, everyone has done. Color you can choose by your own. Even the weight you can choose by your own, whatever you want to. Done?
Yes, ma'am.
Now I am clicking on apply, cancelling it, and now closing it. So now I think it is clearly visible now. Everyone is able to see? Please confirm me. Output is
Yes, ma'am.
visible?
Yes, ma'am.
Yes.
Yes,
Yes.
ma'am.
Yes. Thank you, sir. Thank you, ma'am. So now you can see this is the line. This is the fit line at total we have drawn on this scatter plot. So the residuals, or I can say the residuals, are quite randomly, or I can say equally distributed along this particular line, right? So the variance is, or the equality of variance is, or the homogeneity of variance is maintained by this particular residuals of the data. With the help of this line, we can conclude this. Although with the help of points also we have did so, but with the help of this line also we can say that the points are, or the residuals are approximately equally distributed along this line. So that way homogeneity of variance assumption is met by the residuals. Okay. Done, everyone? May I go up now for
Yes, ma'am.
other?
Yes, ma'am.
Yes. Now coming back to the ANOVA table. ANOVA table significant value is less than 0.05. So that way we can say that there is a linearship relationship between the sales and advertisement, right? Okay, everyone, okay with this assumption, okay with this interpretation?
Yes.
Yes, ma'am.
Yes. Now coming back to this VIF and tolerance value, you can see which, because we have to check the what I can say, we have to check the multicollinearity also. Although in case of simple linear regression, we do not need to report this, but for the sake of understanding, I have calculated this. If you are applying multiple linear regression, so in that case, you need to report this. So I am telling you the threshold value of VIF. It should be less than 10. If there is no multicollinearity, so we will say the VIF value is less than 10. So that means we can conclude this thing that there is no multicollinearity. But again, I'll repeat, in case of simple linear regression, there is no sense of reporting VIF because we are having only one individual variable. Okay? Everyone, is it okay?
Yes,
Can
ma'am.
you please
Yes.
explain the ANOVA one once again? Can you please repeat?
Yes, ANOVA is indicating the linear relationship between the variables. So the ANOVA value is significant as it is less than 0.05. So that way we can conclude that there is significant relationship between significant linear relationship between the sales and advertisement. Okay, ma'am.
Okay, ma'am.
Okay. Now, two things I have told you, tolerance and the VIF. So VIF value should be less than 10 and tolerance value should be greater than 0.2 if we are reporting the multicollinearity. So in both the cases, you can see VIF is less, VIF value is less than 10 and tolerance value is greater than 0.2. So that way we can say that there is no multicollinearity in the independent variables. But again, I mentioned the same thing as we are going for the simple linear regression in which we have only one independent variable. So in such case, it is meaningless to report the multicollinearity. Okay, everyone. But for sake of understanding, I have told you the meaning. Okay, everyone. May I move further now?
ma'am.
Yeah. Now you can go to the. Now you need to check one more thing. I think you need to open your file of advertisement. Everyone has opened the actual data set you have opened. Here you would be now see there would be two columns added by SPSS as we have clicked on cooks, right? So it is the cook's distance for each and every observation. It should be less than 1. So you need to just observe in a go and check whether any of the cook's value is greater than 1. I think you can scroll down till the 30th observation and you can check there is no value of cooks which is greater than 1, right?
All right, ma'am.
So that means what we can conclude here? We can conclude here that every observation is quite what I can say good enough, or we can keep all the observation in the analysis because no observation is influencing our model value or the predicted value. Okay?
Ma'am,
Yes, ma'am.
ma'am, I have only one column here.
Okay, everyone has got one column.
Yes, ma'am.
Yes, ma'am.
Yeah, might be possible. You can see because I have applied 2 times, so you can see 0.0133 values are similar, right?
Yes, ma'am.
That's why it is written by cook once and cooks two. Otherwise, everyone will get the single value because I have applied 2 times. So that's why I am getting the 2 results. So you need to scroll down and you need to check that all the values are less than 1, and that way we can conclude that no observation is influencing our model or the prediction value. Okay, everyone is okay with the explanation of this Cook's distance?
Yes, ma'am.
Now you can go to again output window, and now we are all set for the. Now you can one more thing you need to see here, the chart, that is normal PP plot is coming, probability plot is coming. You need to scroll down and you need to locate this particular chart is also reported by SPSS, and this is indicating us the normality of our variable or normality of the residuals, as it is also the one of the assumptions. So normality of the residuals, you can check there is a deviation in most of the points from the standard line. So we can say this thing that the residuals are not abide by the line, or they are not following the normality distribution, right? This is what we can conclude from this graph, right, everyone?
Yes, ma'am.
Yes, ma'am.
They should be very much clear, or they should be on the line. On that basis of that, we can say that the residuals are following the normality assumption. But we can say most of the points are going beyond this particular line. That way we can conclude that one of the assumption is not met by the data. So one thing you need to always keep in your mind, if you are reporting such kind of results, means even then the data is not what I can say, they are not meeting with the assumptions of the regression, but still you are reporting the results of regression. So you can do one thing for your readers. You can write down the interpretation of all the assumptions, and clearly you can mention this assumption is made, this assumption is made, but this assumption is not met by the data. So that you can mention. So that way, this is now readers' discretion. They will understand on the what particular circumstances or on the what particular assumptions basis you have generalized the results, or you have concluded your results. Okay. So now I am coming to the summary table above the ANOVA table. Now here you can see the R value is 0.862, which we have already seen, but here you need to see the R square value, that is the coefficient of determination value. It is 0.743. So which is the meaning of 0.743 is that the 74.3% of the dependent variable, that is sales, is explained by independent variable, that is advertisement. Okay, everyone, it is clear? The meaning is clear of R square?
Yes, ma'am.
Yes, so that means how much of dependent variable is explained by independent variable, that we will understand with the help of R square. Now talking about adjusted R square, so the question comes when you need to report R square, when you need to report adjusted R square. So when you are applying simple linear regression, that means when you have only one independent variable, in that case you can report R square. But when you are going for multiple linear regression and you have more than one independent variable, so in that case, instead of reporting R square, you should report adjusted R square. Okay, done everyone?
Yes.
Now coming to the last table, that is the coefficient table after the ANOVA table which you are getting. This table will help you to build your model. So here you can see there are it is written in the first line, it is written constant, second line it is written the advertisement. So it is the value of your intercept, it is 5.804, which is significant because its significant value is less than 0.05. Similarly for advertisement, this is the coefficient of advertisement, which is 1.22, and it is again significant because the significant value is less than 0.05. So that way, can anyone tell me what would be our model, how we can create or write our model?
What is this constant?
Why?
It's just a minute, ma'am. Generally, we have line y equals a plus bx, right? So here,
Ma'am, I guess when in the beginning you checked it through the scatter plot, when we had drawn a line, it had given us one equation. Is it the same thing you're talking about right now?
have you seen the equation? What was the equation, sir?
Just a minute. Let me open my output window.
Okay. Meanwhile, I am writing it.
Yes. So the equation was 5.8 plus 1.22x.
Yes, that is
In the beginning, it was
in the beginning you have got it when we have fitted our line at total, right?
Yes, ma'am.
Yes,
It
Exactly.
is similar.
we got it.
So this
So X
is,
here is advertisement and the
yes,
independent variable.
yes. So this way you can say this is your model. So means for every unit increase of advertisement, there would be 1.22 unit increase in sales, right? Got
Yeah,
it?
ma'am.
Yes, so this way, this is known as the model which we have fitted here with the help of regression output. I'm going to the output. I'll show you again. Yes, you can see here 5.804. This is your constant or this is your intercept value. Advertisement value, that means it is the coefficient value of advertisement. Now, if you will increase advertisement by 1 unit, so there would be 1.22 unit change in your sales. So that means if we will see the hope of company, so I can, what we can conclude, yes, that the advertisement is heavily impacting our sales, because you can see the R square value is 0.743 and it is indicating us, that means approximate 74.3% of sales is explained by or influenced by the advertisement, right? Everyone got it?
Ma'am, I have one question. I mean, it is not related to the output you are telling. Generally, what happens is when we see certain research papers, now they have written the research papers which have used a regression analysis. Now they derive certain regression equations using alpha and beta. Now those alpha and beta are also dependent on independent values, ma'am.
Can you tell me a equation? Are they writing in the equation form, right?
They're writing it into an equation form. Yes, I don't
Yes.
have a
I
paper.
think this would be A.
Yes.
A would be treated as alpha and B is treated as beta, right?
Yes.
Yeah, you can write. They are the same. This is mathematically we are writing, but statistically you can write in that way also, sir.
So I just got confused certain times, but indirectly you resolve this confusion of mine today by simplifying it in a statistical manner, because alpha beta is something very less understandable, especially with the people of management. So that's why.
Yeah, sir, there is no issue. You can write A, B, but generally in statistics, generally the equation are written in that form only. So you need to write in that fashion also, but the meaning is similar.
Thank you.
Okay, sir. So anything else? I think we are done. Yes, Kiran, ma'am.
Ma'am, there is a Durbin-Watson value. You have not explained that.
Oh,
It is
sorry. I forgot. Just a minute, ma'am. Can you tell me what value we are getting of Darwin-Watson? I need to check. It is 1.31. Yes, ma'am. Generally, it should be in between 4. Generally, the value of Darwin-Watson is in between 1 to 4, and it should not be less than 1, or it should not be more than 3. It should be in between 1 to 3 generally. So if it is in between 1 to 3, we can say that residuals are independent. They are not influencing each other. Got, ma'am?
Yes,
ma'am. Got it? Yes. So thank you. I think I forgot to tell. Thank you so much. Anything else?
Ma'am, I have a doubt.
Yes, ma'am.
Ma'am, ma'am, in case if we have the outliers on the box plot, so what we need to do in that case?
For your dependent variable, right?
Yes.
So I think, ma'am, I think from since first day I am telling this thing. I have been telling this thing to you, every one of you, that it is totally your discretion, because because outliers is there and the outlier is significant. Significant means if they are represented by the asterisk sign, right? Generally, SPSS use asterisk sign to show you that whether the outliers are significant or not. So in that case, you need to decide upon whether you are going with the variable or whether you are going with that particular data point or not. If you want to drop, you can drop. Again, I tell one thing, that is totally your data or totally your research study. So you need to defend. If you are keeping it, and if you are able to defend that, yes, with the outliers also I'm going, and it is not impacting our results, you can go with. Or you can do one thing, you can keep that and can calculate the result, and you can remove that and can calculate the result, and that way you can compare both the results. And if you are okay with the results, so accordingly you can decide upon how you will go.
Okay, ma'am.
Okay, ma'am. Thank you. So anything else?
मैम रेजिडुअल्स का एक बार बता दो.
Vritti, ma'am, what you are asking me means what I need to tell about
मैम
residuals.
रेजिडुअल स्टैटिस्टिक्स वाला जो टेबल है उसे किस तरह से इंटरप्रेट करना है?
Which table, ma'am? Just a minute. I think I have stopped sharing my screen. Give me a second. I'm sharing my screen.
No issue.
Ma'am, output window is visible.
Yes, ma'am, it's visible.
So can you tell me which graph I need to tell you?
Ma'am, residual statistics. Yeah, this one. Yeah.
Ma'am, this generally you do not need to report. Here you can see whatever the predicted value, whatever is the standard predicted value. This is only telling you the minimum, maximum, mean, and standard deviation value. So this is not you need to report. This is the extra output you are getting. So you do not need to report this.
Okay, ma'am. Okay. Thank you.
Okay, most welcome, ma'am. Anything else?
Just wanted to thank you, ma'am, again. So I'd like to say you something. Actually, the main motive of me joining this workshop was for this particular topic only, because I am familiar to the other techniques like ANOVA and independent t-test and factor analysis, but regression was something I was lacking, and I was not much confident on how to use and report. So my purpose today has been solved. So thank you so much for the same. Just thanks.
Thank you, Gaurav sir. It means a lot for me. If I was able to make you clear about the regression and correlation, so I think I'm more than happy if I was able to do the justice with that. Thank you so much for your feedback. Thank you.
A request is there.
Yes, Sonia ma'am.
Ma'am, is it possible that tomorrow we can have one or two example of research paper, how the things are done?
Means of any particular test you're asking, ma'am?
No, ma'am. I just want to see any research paper in which the things are done.
So in what context you want to see the research paper? You want to see
basically
no.
what I'm trying to understand from Sonia ma'am's understanding is she wants that we are able to apply the test on the basis of some real data. That is how it is incorporated into a research paper, right, ma'am?
Is it, ma'am?
Yes.
But Sonia ma'am, usually what happens generally when I'll show you the research paper or something like, so we need to have data of that, because on the basis of because in research papers generally people are not giving the data. You would be able to see there are only result interpretations are given, and on the basis that they are concluding this study and they are making these suggestions. So this is all there is there. But I'll try, if I would be able to find some good paper, that I'll try to discuss. I'll try that, ma'am. Okay, Sonia
Okay,
ma'am.
ma'am.
Yeah.
Thank you, ma'am.
Most welcome, ma'am.
Thank you, ma'am. Hello, ma'am.
Yeah, thank you,
Hello,
Jagriti ma'am. Thank you, Bhavna ma'am. Yes, Bhavna ma'am.
Ma'am, I want to ask one thing, that many a times we get dot in output window. So
Dot.
what does it indicate? Dot,
Ma'am, where?
In regression analysis output, we saw that dot. What does it indicate? Why do we get?
At which section you are getting dot, ma'am? Because so many outputs we are getting in.
The correlation, correlation output, correlation. Before correlation, there is a one.
I understood, ma'am. Probably you are saying about the correlation output under the regression, right?
There is 0 significant. Sales and advertisement. Sales, there is a dot and then 0 was there.
Just a minute. I need to come to the output. Are we getting similar, right? I am also getting the same. Is it?
Yeah.
Just a minute. I'm just showing you the output. I think you are talking about what I'm understood your point. Just a minute. Window is, I have shared my window, ma'am. It is clearly visible, right? Visible, ma'am?
No, ma'am. Not visible.
Anyone?
ma'am, visible.
Yes, ma'am.
Bhavna ma'am, I think it is visible. Please check. You have. You are able to see or not, or do I need to again share? Bhavna ma'am, it is visible to you or not? Have you pinned my screen, ma'am? Bhavna ma'am? Bhavna ma'am, are you here? Bhavna ma'am? Can anyone confirm me? I think Bhavna ma'am is not there. So do I need to explain this or not? Bhavna ma'am, am I audible or not? Can anyone confirm me?
Yes, ma'am, you are visible.
Yes, ma'am, you are audible.
Okay.
Screen is visible.
Okay. So I think Bhavna ma'am has left maybe due to some network issue or some other issue.
Ma'am, I have a doubt.
Yes, ma'am.
Ma'am, in table coefficient, if we get our sales value greater than 0.05, then in that case, what will be our interpretation?
In this coefficient, ma'am?
Yes, ma'am.
Sales value. I think we are
Like,
reporting
sorry, advertisement.
advertisement.
Yeah.
So in that case, ma'am, here you can see in the output T values is also given, and on the basis of T significant value, we are saying this thing that whether this particular coefficient is significant or not. So if this value is greater than 0.05, so that means it is approximately 0. This means might be possible there would be some other value in that case. So in that case, the advertisement coefficient would be treated as it's approximately 0 and it is not contributing to your sales. Okay?
Okay, ma'am. Thank you.
Most welcome, ma'am. So Bhavna ma'am, are you back? Do I need to discuss the correlation point which you are saying to me or asking to me? I think no. So I think we are done with today's session. Any other query if you have?
One last question from my side. R value is sometimes given in validity also. I have seen in validity also they show R value. So is there any, I mean, apart from regression, R value is also there in validity?
Yes, ma'am. In factor analysis also we are using the correlation value, right? I said this thing also. So
Okay.
R is as I said when we were discussing the correlation, I said this thing. It's a building block in the statistics. In each and every advanced studies, we are getting the R value. We are generally reporting also because most of the tests, because generally if there is no relationship, so in that case, I think it is no use of applying any further test, right? So generally, we are getting a correlation value in most of the advanced studies.
Okay, ma'am. Okay. Thank you, ma'am.
Okay, most welcome, ma'am. So I think, yes, Kiran, ma'am.
Ma'am, when we are applying regression, there is a plot section. There is a predicted and residual value. Where will you just put the value? Predicted on the x-axis or the y-axis?
Residual values would be on y, ma'am. X value on x-axis, you need to put the predicted value.
Okay, thank you, ma'am.
Most welcome, ma'am. So I think I am done. Anything else you have, you please ask me, or then otherwise we can wind up the session. I think no more query. Ajay sir, can we wind up now?
Yes, ma'am. Thank
Yes,
you
sir.
so much, ma'am. Thank you.
Thank you, sir. Thank you, Ajay sir. Thank you, every participants.
Thank you,
for
ma'am.
listening me. Thank you, Sharmila ma'am.
Thank you, ma'am.
Thank you,
Thank you, everyone. Thank you so much.